What we have here, guys, is second order differential equations, okay? So what you'd have here is the second derivative is frozen. So you have the second derivative. The first one would be the second derivative of dx equals y 2 times dy dx, given that y equals 0 and dy dx equals 1 when x equals 0. Now, what you use is what sort of like a placeholder, okay? So what you sort of say is that see the way you're always given dy dx equals 1. What you're going to do is you're going to choose one letter to represent dy dx, and you usually just call it v. So you're going to let v equals dy dx. Is that okay? So you let v equals dy dx. What was I going to say then? What does that make the second derivative? d2y dx squared. So what does that make that one? It's like the d dx. It's the derivative of d. Would you agree it's the derivative of the first derivative? Yeah? That makes sense? The second derivative is the derivative of the first derivative. Therefore, it's the same thing as the v dx, because this part here is now represented by the letter v. So the second derivative, will somebody close that door? The second derivative is the v dx. Everybody cool with that? So, what we can now rewrite this one, we can rewrite it as what was it, dv dx. Okay, so we can rewrite this as dv dx is the second derivative. So that's that part done. Equals 2 times what? 2 times v. Okay, what happens next, guys? It's very similar to what we dealt in the last chapter, isn't it? Bring the 1 over v to v, and then the other side is going to be 2 dx. How do you match up their limits? So go back to the top. How do you match up their limits? When dy dx equals 1, dy dx, that's basically a v now, isn't it? When v equals 1, x equals 0. And then we obviously put in their letters on the top. No problem there, okay? So we're going to get is ln v bracket v minus 1 equals 2 times x to 0. This is going to be ln v minus ln 1 equals I didn't integrate that properly that time, did I? It's 2x, isn't it? So when you replace 2x with x, it's 2 times x minus 2 times 0. ln v therefore equals 2x. Use your log rule. Log to base ev equals 2x. Therefore v equals e to the power of 2x. Everybody cool with that? Now, how does that link back in? Well, you recycle what you just learnt. We've now just learnt that phi equals e to the 2x. Look at the original question. The original question is what, guys? The original question is there's a y on top and there's an x on the bottom. What does that mean our answer must look like? Y on its own and some random formula with x on the right hand side. Have we achieved that yet? We haven't quite achieved that yet because there's still the phi there. So the logical choice would be then is that phi is dy dx, so therefore dy dx is obviously equal to e to the 2x. And then we're going to do the same trick again. It's basically 2 questions in one. Okay, and they're called second order separable equations. Okay, so second order separable. So integrate both sides. Now what limits do we use this time? When y is 0, x is 0. And what's the other one? It's 1 dy, by the way. And then y and x. So what we get when we integrate 1, we get y times y and 0 equals, anyone know how to integrate that? E to 2x. Then what else is there? Differentiate the power and divide it by that power. And what do we get after that, guys? Y minus 0, which is just y, equals e to the 2x over 2 minus e to the 2 times 0 over 2. What's e to the power 0? 1. So e to the 2x over 2 minus a half equals y. Okay, if I was to factorize that out, it would be y equals a half e to the 2x minus 1. Is that right? Okay, let's try another one now. See, these ones aren't too bad. How much time do I have left? 10 minutes? Plenty of time. Okay, this one here. We have the second derivative equals 6. Okay, I'm going to create a placeholder for that. So I'm going to say that because the dSdt here is on its own, I'm going to say phi equals dSdt. Therefore, d2 dst squared, it's basically the derivative of the first derivative. And what is dSdt again? So we're now dealing with the v dt. That makes sense? It's the v dt for the second derivative, so it's the v dt equals 6. Cross multiply, the v equals 6 dt. Integrate both sides. And what happens when you integrate? S, integrate both sides, yeah. Phi equals 4 when t equals 0, t on top, phi on top. When I solve this question, what will I be left with? When this answer is done, what should I have at the very end? S equals some sort of t equation with only t in it as the variable. Until I get there, I'm not done. So then, what happens next, guys? Looking at this here, we're going to say, okay, that is going to be what's a phi, integrate 1, so it's going to be phi from phi and 4. Then it's going to be 6t from t and 0. Phi minus 4 equals 6t. Therefore, phi equals 6t plus 4. How about that? Recycle it back to the top. You have phi equals 6t plus 4. It's not the answer we're looking for. What's phi again? What did I say phi was? Phi is dSdt. Now I have dSdt equals 6t plus 4. What's the next step? ds equals 6t plus 4 dt. And after that, integrate both sides. When s is 0, t is 0, your t, your s. Integrate. S is going from s to 0, and then it's going to be 3t squared. Yeah? 3t squared plus 4t from t to 0. And the zeros don't matter, so it's just going to be s equals 3t squared plus 4t. They're alright, aren't they? Okay, I'll try 5 is a bit harder. Oh, wait a second. Actually, what we have here, guys, is question 6. We have a second derivative with y on top of x. This means that my answer to the full question would be y on its own and some formula with x on it. In order to solve these, we're going to use a placeholder letter called v. Phi is equal to the first derivative. Okay. Therefore, the second derivative is the derivative of the first derivative, and the first derivative is v. So second derivative is the v dy. Oh, sorry, the v dx. Excuse me. That's an x. Okay. So I just want to go back to that for 1 second. Yeah, it's the v dx, not the v dy. Oop. Okay, that seems to be magic. The v dx by the y dx. Okay, so long story short, the v dx is the second derivative. Okay, put that into your formula. The v dx ends up to be equal to 2x. Cross multiply, the v equals 2x dx. Integrate it. Now, it says that this is v equals 1 when x equals 0, x on top, v on top. Integrate both sides. You're going to be left with v dv. Oh, sorry, not v dv, just v. And then it goes from v to 1. And then the other one, guys, x squared from x and 0. You're going to get phi minus 1 equals x squared minus 0 squared. The 0 squared doesn't really need to exist there. Bring over to 1. Phi equals x squared plus 1. Recycle. So you're going back to the top again. And what you're going to do this time around is that you know that phi equals x squared plus 1. You also know that phi is the y dx. So change that phi back to the y dx. Now, repeat system. So we're going to go to y equals x squared plus 1 dx. Integrate both sides. Now what happens when what are our limits for this one? Y is 10 when x is 0, x up here, y up here. Bring it down, and we're going to get a integral of y to 10. Integral of, when you integrate x squared, you're going to get a third, x cubed, plus x from x to 0. You're going to get y minus 10 equals a third, x cubed plus x. Then bring the 10 over to your side. Y equals a third, x cubed plus x plus 10. Is that alright? Okay guys, so look, do 12F and try and get questions like 1, 2, 4 and 6 in. Those questions there are pretty good for what we just did there, so that's 12F. I did 1, 3 and 6.